Welcome everybody to the next video in our series on computer programming for mathematics. Today we will be looking at a flow control example using the game of Fizzbuzz. Alright, so let's take a look at what the example problem is. So the game of Fizzbuzz, if you are not familiar with it, really consists of listing all of the positive integers from 1 up to some number n, and we're going to put in the conditions that if that number, so if a number is divisible by 3, then we're going to replace the number with the word fizz. And if the number is divisible by 5, we're going to replace it with the word buzz. Now, what happens if it's divisible by both the 3 and the 5? Then we write the name Fizzbuzz. So pretty simple game, pretty straightforward. You can see that basically this is just kind of checking conditions, and so it's going to involve some logicals, and it's going to involve some loops. So pretty simple, pretty straightforward, but kind of an interesting game to play. So what we want to do is write a program to play this game for n up to 100. Alright, so let's see if we can actually solve this problem and write a program that will play the game of Fizzbuzz. Alright, so we want to know, so we know that we want to go through a loop. So for all of our positive integers from 1 up to 100. And so let's say that we have this maximum value that we want, n being 100. Okay, so now we need a loop that loops through all of those numbers. Well, there comes in our command of range. So for I in range, and so the range is going to either start, stop, and step. So we want to start at 1, and we want it to stop at n equal to 100. So that means we have to give the stopping value 1 more than the value that we want to actually stop at. Okay, and so this will run through our list. So this will run through all of our positive integers. If we're not sure, then let's print it out, and let's say just print I equal to I. So let's have it print that. Let's save it. Let's run it and see what happens. Source must be saved. Yes, save it. Whoops. I got a little bit of invalid syntax. Oh, there, I had an extra S. Don't know where that came from, but there it is. So now let's try running it again. And sure enough, it runs through all the positive integers from 1 up to 100. Okay, so we know that's actually flowing the way that we need it to. Okay, so that's good. Now let's get to some of our program now. So let's get to actually playing the game. Okay, so it's printing those values. Now, as we're playing the game, we're knowing that if an integer is divisible by 3, we're writing fizz. If it's divisible by 5, we're writing buzz. And if it's divisible by 3 and 5, we're writing Fizzbuzz. And so for that, let's say if I divisible by 3 and 5, since those are both prime, if it's divisible by 15, so there's our condition. So remember the parentheses is really just modular arithmetic. So if this is saying that if the remainder of I divided by 15 is going to be 0, then what do we write? Then we print Fizzbuzz. Okay, so if it's divisible by 15, that's what we'll print. Now, if that's not true, so if that is true, this is what we're going to do. What if it is not true? Well, now we have the term, well, elif, so else if, so if it's not divisible by 15, if it is divisible by 3, so if I is divisible by 3, so if I mod 3 is 0, then what do we print? Then we print Fizz. Elif I mod 5 is equal to 0, then we print buzz, and else we need to print I. And so basically that's going to run through all of our positive integers, and it's going to say, all right, are we first divisible by 3 and 5? So if we're divisible by 15, that will do it. Another way of writing that would be if I mod 3 was equal to 0 and I mod 5 was equal to 0. So now we're kind of checking both of them, and we're using the condition and. So if I is congruent to 3 mod 0, or if I is congruent to 0 mod 3, and if I is congruent to 0 mod 5, then we would write the term Fizzbuzz. So if both of those are true. If it's congruent to 0 mod 3, we write Fizz. If it's congruent to 0 mod 0 mod 5, then we write buzz, and otherwise we just type the letter that we've got. And so now let's see what happens whenever we're doing this. Let's just only do the numbers instead of going all the way up to 15 or all the way up to 100. Let's just do the numbers up to 15. So what happened there? We had the number 1, the number 2, the number 3 was divisible by 3, so that one gives us Fizz. 4, 5 gives us buzz. 6 is divisible by 3, so that gives us Fizz. 7, 8, 9 is divisible by 3, so we get Fizz. 10 is divisible by 5, so we get buzz. 11, 12 is divisible by 3, so we get Fizz. 13, 14, and 15 divisible by both, and so we get Fizzbuzz. Okay. Now, if I want to kind of maybe visually inspect that a little bit more for slightly higher values, so let's go all the way up to 30. Okay, let's have it print a little bit more information. So let's have it print the value of I. So let's say I equal to something I, and then the value that it's printing out is just being Fizzbuzz. So we also want to print I. Tab it over, print Fizz. And finally, if I is equal to I, then a tab and we print buzz. Else print, just for consistency's sake, if I is equal to I, yes, tab, and that is I. And now let's see what happens when we run this program. Okay, so we have I being 1, we get 1, I being 2, we get 2, 3, we get Fizz, 4, we get 4, 5, we get buzz, 6, we get Fizz, 7, we get 8, 7, we get 7, 8, we get 8, 9 is Fizz, so we know that it works all the way up to 15. 16, 17, 18 is divisible by 3, so we get Fizz. 1920 is divisible by 5, so we get buzz. 21 is divisible by 3. 22, 23, 24 is divisible by 3. 25 is divisible by 5, so we get buzz. Until we get up to problem number 30, in which case now 30 is going to be divisible by 3 and 5, and so we get our term Fizzbuzz. And so this particular program seems to be working all the way up to 30. So if we play it now, what do we want it to play to? We want it to play to 100. And so if I really only just want to print out the original results, which was what the game was doing, I can go back, get rid of the extra information that I was printing. Whoops, one too many, and get rid of that extra information. And get rid of that extra information. And so playing this, we can see that yes, we are now getting a successful game of Fizzbuzz all the way up to n being 100. Okay. So again, kind of taking a recap of that code. It's nothing more than a range and the if and else if being those conditions. So the if we try this one, try this condition. If it's true, do this command. If it's not true, check the condition on the next else if. So elif, if this one's true, run this command. If it's not, try the condition on the next elif. If that's not true, or if that's true, go ahead and run that command. If it's not true, then otherwise or else we just want to print I. And so we check our most restrictive condition, then we check our first condition, check our second condition, and then finally down, if none of those actually work, then we print our original value of I. And so there we have our game of Fizzbuzz in just a few lines of code. So I hope this has been a good demonstration of loops and conditionals. So if, else if, and else. So I hope you enjoyed it. I hope you found it informative. If you liked it, then like it down below, and I will see you guys next time.